How is it determining where the ball is?
So every one of those 7 joints in the robot arm has a servo, and built into that servo, basically that servo control loop, which is really high refresh, they have 2 torque sensors. And so it's actually looking at the torque on the joint. So just like a human, when I pick this up, my brain knows the weight and where this is in space by the weight and how it's presented to my nervous system, right? So the robot has a very similar system. And so it can literally feel where that ball is while it's trying to balance it and then drive it into a circle. Just trying to get to my videos here. Naturally, the meaning thing's covering up all my videos. All right, this one. Okay, so another quick video just to show the robot actually in action. So in this application, we're picking these parts out of a cryo tank. And the idea is that the liquid nitrogen's at minus 320 degrees C, and it's shrinking the part basically. And so it picks the part. We have a gantry overhead that's moving the robot out. And then the robot's going to reach out into this CNC machine where they had just machined these pockets. And it's going to find the pocket, and you kind of see it wiggling around, searching, and then it slides the part in. So I just thought you guys, since we're all here and like robots and cool stuff, you might get a kick out of seeing the industrial side of it a little bit. So that's what we do for our day job. The fun stuff. So this is a tank that we've been working on for quite a while. So this is this guy here. So actually a friend of Ken and Chip's, and probably some of you out there, John Olson, designed this track system, this extrusion some years ago, and then ended up passing it on to us. And so we took it from there and designed this tank system. And so fully metal track system. We designed the sheet metal enclosure to hold everything together. It's got some basic slides for the tracks to ride on. And it turned out to be pretty darn doable. That's it running through our machine shop and on the rocks out in front of our shop. But we've ran it around quite a bit, and it holds up pretty decent. So this is something that we kind of, our goal is to make a product at some point. But right now the cost is pretty high because of all the machining for the parts and the sheet metal. So anyways, it's a pretty fun little thing. I wish we could drive it around in here, but I'm pretty sure Ken wouldn't appreciate us chewing up his carpet. So, and then the other cool thing we have is, and I'll have Emily hold it up for you so you guys can see it. So we can find the video. So this is a Core XY system that we're developing, and hopefully going to have available pretty soon for Ken to offer on the website. We spec'd our own custom servos, and so these servos that are on there are a closed loop, full-blown servo, 17-bit encoder. And then what's unique is the driver is built right onto the back of the motor. And so basically all you feed this is 24 volts and step and direction signals, and then you're off and running. And we're working with Chip right now. He's helping with some of the programming to make the motion control system to run this. And it's pretty high speed, as you can see. I'll run the video again. This was kind of like a generic CNC controller that we rigged up just for testing the mechanical system. But hopefully soon we'll have this set up where we can run it all off of P2 with the P2 actually doing all the motion control calculations. And what Chip's got set up right now is pretty cool. It actually with one servo, we can send it to a final position using acceleration, jerk, and then deacceleration, and then jerk on the decel side. And so we've got a lot of the core math and stuff, kind of worked out with Chip's help. And so I think we're not too far from having this ready to start selling. And so we're hoping this kit, and it's kind of what I'd hope to get some feedback from you guys, is we're kind of right now we're coming in at about $500 for the kit, and it's hoping for 300, but you know how it is when you're developing stuff costs money. But yeah, that's pretty much what we do in a nutshell. Any questions?
Can you show how the two motors that are actually stationary do that?
Yeah, you hold that for me. All right, so let's see if I can do this without. So the two motors, it's basically a Core XY system. It's kind of a new twist on a Core XY. So if I turn the motor in opposite directions, we get an up-down motion, or what I would call probably the Y. If I see if I can do it, if I turn just one motor, then we get like kind of like a cross motion. And if I turn them opposite directions or together, then we get the other dimension. So
The motors are stationary unless you add another motor out on the end with
and we do have a small little stepper motor for a Z axis. We're still kind of working on a theta axis, but eventually we do want to have a theta. So any other questions? Well, it's based on a Core XY design, but it's just kind of running the belts in a slightly different way. So I don't know if there's any standard name for this exact configuration, but the closest thing out there is Core XY. Oh no, we designed and built everything you see here. Yeah.
I mean, you designed the whole thing. The only thing you want on there was motors, and then the rails and the bearings. The rails fit the bearings.
Yep. Yeah, all the linear rails we buy from a vendor. The bearings are actually our own specification, but we do buy those from another vendor pre-built. And then of course the homing sensors we add, and then this little Z-axis stage. But all the basic mechanics, the belt system, all that we design in-house. So, and the same with the track robot. Everything here we designed and built and machined in-house. We're fortunate to have a pretty wicked machine shop, so we get to do some fun stuff from time to time. Yeah, exactly. I mean, right here we were just drawing with a pen, but you could pretty easily, I think, put like one of those, I don't know what they call them, but the little lasers you can buy nowadays for $200 and actually cut like, thin plastic.
Yeah.
So.
Hey, what are you thinking about the interface for like a person that wants to draw something? Like, I guess the G code side of it.
There's and I don't remember the name of the software, but one of my guys that actually set this up for the demo you see in the video here found some software where you can pretty easily bring in like a picture, and in our case, our logo, and then it builds all the G code for you. And it's a free software you can just get off the web somewhere. I'll have to get back to you on what it's called. I don't remember the name, but.
And then the G code to controlling the motor side, that has to be done, right?
That still has to be done,
That's
yeah.
the big piece.
That's the big piece.
Okay.
Yeah. That's the big piece. So we're getting closer. I think we're not too far off, but doing the G code portion, there's probably about 5 main G codes you'd really have to get it to do something like this. So it's, you don't have to support the whole G code system. So yeah.
Any more questions for Doug? Nice.
All right.
This is also a product that's not going to be actuator, something like that. But it's one servo that can close and then lift an object without regards to the object's width inside. So once it grabs it, the remaining force, the remaining motion of the servo goes towards lifting it. So whether it's like a felt tip pen or a ping pong ball, which is a big programming benefit to students because all they have to worry about is the open and closed servo position. And it's one servo.
Well,
And they don't have to worry about current
I
feedback
figured we could
issues.
just
You know, it's like simplifies picking
take a
something
look
up.
at
from
Ken's
but they don't, the challenge is they don't know how simple, you know, really a teacher may not know what they're paying for. It's so expensive that it makes the programming job so easy. It's one of those things that we have to carefully communicate. So Chip's gonna talk about the 8-in-1 arcade game. Right, so come on up here, Skippy. Good boy. All right.
Okay.
Chip, I can show a video